So let's use all these steps to graph this function. The first point is to check end behavior. Now we see that the graph is function is x cubed minus 9x. So leading term is x cubed. The coefficient is 1, which is positive, right? And the power degree is odd. So let's see what happens in the graph, right? A rough idea. When x approaches to negative infinity, we have the leading term 1 times x cubed. This is positive times negative. X is very negative, right? X is approaching to negative infinity. Negative raised to power 3 would be negative. So the product would be negative. So the graph goes down on left side. What happens when x approaches to infinity? Leading coefficient is 1 times x cubed. This is positive. X is a positive number, so positive power 3 will be positive 2. So the answer is positive. So the graph is going up on right side. So that is your end behavior. Next, let's find zeros of your polynomial function. How do you find zeros? You write f of x is equal to 0. That means x cubed minus 9x is equal to 0. We factor it. X factored out. X squared minus 9 is equal to 0. So we have zeros to be x is equal to 0 or x squared is equal to 9. So x is equal to 0 is 1, 0, and the other is x is equal to plus minus 3. So we have 3 zeros. X is equal to 0 has multiplicity 1. X is equal to 3 has multiplicity 1. And x is equal to negative 3 also has a multiplicity 1. So each of them have odd multiplicity. So they all are cross points. Okay. So what do I know until now? This is my graph grid. Somewhere at 0, there is an x-intercept. It's a cross point. Somewhere at negative 3, it's a x-intercept. Somewhere at 3, it is an x-intercept. The graph goes down on left side. The graph goes up on the right hand side. Negative 3 is a cross point. So graph has to go up and it has to pass through negative 3. Now the graph has to pass through 0 also. So it has to turn back. And it passes through 3, so it has to turn back and it has to go up. Something like that roughly. Okay, so just by using the zeros and the end behavior, I have a rough idea what my graph is. Then what we can do is we can find a table of values in between to fix the place. Say, what is x? What is function's value when x is, say, 1? The function was what? X cubed minus 9x. So at 1 it is negative 8. So here that means at 1 it is going really down at negative 8. At 2 it will be 2 cubed, which is 8 minus 18. So that will be negative 10. At negative 1 it's negative 1 plus 9, 8. And at negative 2 it is negative 8 plus 18, which is 10. So now we can fix the positions of the graph after drawing the accurate endpoints. Now we have the graph goes down on the left. It passes through 3. At 2 its value is negative 2, its value is 10. At negative 1 its value is 8. So the graph goes up from 3, negative 3 goes at negative 2, 10 and goes back, passes through 0, 0. At 1 it is negative 8, at 2 it is negative 10, at 3 it passes through 0. So it has to go here and that 3, 0 and it goes up on the right side. So I know this is not looking very nice. We can plot it on the decimals to be more accurate, but we can check our behavior. So let's plot it on the decimals. X cube minus 9x. See, it's passing through negative 3, 0 and 3 at here low and the high, right? So that is the rough shape. So we got almost the shape. We can always use more points to get accurate values. Let's look at graph of one more. The first step is to check end behavior. For that, we need the leading term. Where is the leading term? That is, now this polynomial has to be solved first. So I'm going to find the leading term in each of them and multiply. The leading term would be equal to negative 0.1 times x times x times x square. So that would give me negative 0.1 x raised to power 4. So I noted, so leading coefficient is negative and the degree is even, right? So what happens on the left hand side, if the leading coefficient is negative and the degree is even, the graph goes down on left and it goes down on right. So that is my first observation. Then we can find the zeros of your function. So for finding zeros, we have to put g of x is equal to 0. That means negative 0.1 times x minus 1 times x plus 2 times x minus 4 square is equal to 0. What will be the zeros? X is equal to 1, x is equal to negative 2 and x is equal to 4. What are the multiplicities? For x equal to 1, this is 1. For x equal to negative 2, it is 1. For x equal to 4, it is 2 because it's repeating 2 times. That means this one, the first one, is a cross point. This is also a cross point. And this one is a touch point. Okay. So let's see. We have roughly, we have 3 zeros at negative 2, at 1, at 4. The graph goes down on the left side. The graph goes down on the right side. It is passing through at negative 2. Negative 2 is a cross point. It has to come down to pass through 1. But at 4, it's a touch point, but then it turns back and go. So these two at 1, they were cross points. And this one here is the touch point. Okay. Example number 8, it says for each polynomial function graphed, determine the minimum possible degree. So we do not know the equation of the function. We know that this is the graph of the function. I can observe the x-intercept. That's going to give me the zeros, right? What are the zeros? There is negative 4, there is 1 and there is 3. Each of them has multiplicity to be odd multiplicity because each of them is cross points, okay? But how do you find the minimum possible degree? Minimum degree, minimum possible degree is number of turning points plus 1. How many number of turning points this graph has? The turning points are here and here. 2. Turning point is where the graph changes from increasing to decreasing. 2 turning points plus 1. So the minimum possible degree for this graph is 3. Okay. Let's look at the second one. Minimum possible degree is equal to what? Number of turning points plus 1. How many number of turning points? 1, 2, 3, 4, 5. So minimum possible degree would be 5 plus 1, which is equal to 6. Let's conclude everything by doing these concept connection. A polynomial function defined by this function where an minus 1 and so on are the real numbers and an is non-zero is called a polynomial function. A quadratic function is a polynomial function of degree 2. A linear function is a polynomial of the function degree 1. The value of x in the domain of the function for which f of x is equal to 0 is called 0 of the function. What is the maximum number of turning points in this? So maximum number of turning points will be given by n minus 1, where n is equal to degree. Degree is what? 6 for this polynomial. So maximum number of turning points would be 5. If a graph of polynomial function has 3 turning points, the minimum possible degree of the function would be 3 plus 1, which is 4. If c is a real 0 of the function with the multiplicity 3, does the graph of the function cross x-axis or touch? 3 is the multiplicity. This is odd. That means it has to be a cross point. If c is a real 0 of polynomial function with multiplicity 6, 6 is even, that means it has to be a touch point. Suppose f is a polynomial function, a is less than b,